Okay, so unit 1 with quadratics was the graphing part. So this was one of the forms of a quadratic. If you remember seeing something like that. Okay, so when we were dealing with graphing quadratics, there was two major ideas that we needed. What's the vertex and what's the slope pattern? Okay, so the vertex is the h and the k, so it is 1, positive 1, comma, what? Positive 1, comma, negative 7, right? Opposites. Because the formula minuses the h, so you have to do the opposite of it. And the slope is the multiplier, so in our case, the multiplier is a 2. Does this open up or down? Which way do you think it's going to go? It's going to open up. Do you remember what you're looking at? Why it's opening up? Because the slope multiplier is positive. That's why. Okay, and the axis of symmetry. So remember what the axis of symmetry was? It's this vertical line. It cuts it down the middle. It folds it over. And it's always x equals, and what is the x value it cuts through? It cuts through an x value of 1. Okay, domain. How far left and right does your graph go? So it's going left forever and right forever. So negative infinity to positive infinity. And the range is, what's the lowest value? What's the height there? This lowest is at a height of negative 7 to a height of infinity. Okay, how does this transform? There's a shift. Which direction does it shift? Left, right, up, or down? Well, obviously, if my vertex is over at 1, it would have shifted right 1. And negative 7, so it would shift down 7. And what does the 2 multiplier do to the arms of it? Do you remember that? The arms? Yeah, it narrowed. Kind of like that, like it gets skinnier. And what is the Y-intercept? Okay, so when you find a Y-intercept on anything, you're looking for where does it cross this axis, which is where the x value is 0. When x is 0, what happens? So I put 0 in for the x. That's all I did. Okay, so now we have to do the math on that. So 0 subtract 1 is negative 1. Negative 1 squared is 1. And then we're going to have to subtract 7. So y is negative 5. Okay, we're going to graph. So we're going to go 1, -7. Okay, so now this was, if we go over 1, 1 squared means go up 1. If you go over 2, 2 squared means you're going to go 4 up, 3, 9. Remember that normal pattern? But we don't have normal. We have a multiplier of 2. So we're actually going to go 1, 2, 2, 8, 3, 18. Okay, so 1 over up 2, and you do it from both sides. 2 over up 8. And then you can also see our axis of symmetry was where x is 1. That was that line right there. And look, we're crossing the Y-intercept. That's good. It's -5, right? You want to match what you did in your algebra, so that's good. Okay, number 2. Another quadratic, but this time we're in general form. So that would be the style on this one. Okay, so how do we find the vertex in general form? Do you remember this one? It's different than HK. Remember that? -b over 2a. You used that a few times. Okay, so -b. So what's the opposite of RB? So +6 divided by 2 times -1. So that's -3. What do you think I referred to with PI? Do you remember what you would do with -3? What are you going to do? Plug it in, right? Remember that? So negative of -3 squared minus 6 times -3, subtract 3. Okay, this is a little bit tricky with all these negative signs, so you're going to have to think like this. Square it first. This squared is 9. Then times negative makes -9. Negative times negative makes +18. So that ends up being 6. I see a lot of mistakes here. That doesn't work very well. This is what you would want. -3 squared. -9 plus 18 is +9. +9 subtract 3. Oh no, the whole thing. These 3 things added together make 6. Do you see it though? That's good? Okay. Okay, and what is the slope number? What is the because that's the multiplier. So A is -1. That's the number in the front of the x squared. So what does that tell us about how this is going to open? Now it's going to go down because it's a negative multiplier. Axis of symmetry. So what's that line? It's always x equals, and it's going to cut through the vertex, so it's going to cut through a -3. Often a mistake there is forgetting x equals. Domain, it's the same, it goes outward. And the range, so this time the lowest is -infinity to the highest height of, what's our height here? 6. Do you notice how I'm using round brackets sometimes and square brackets sometimes, right? Round is an approximate, square is an exact. And the Y-intercept, just like that, a snap of a finger. -3. And why is it that? Because 0 plugged in for x, right? If I plug in 0, really this is just gone. Those are all 0. Okay, so let's go to -3, comma 6. Okay, so now 1, 1, 2, 4, 3, 9 is normal. We're not quite normal. We have to multiply by -1. So then you're going to go 1 over 1 down. Two over 4 down. By the way, your Y-intercept is -3. Would you ever know how to find the symmetric point if I asked you to find the symmetric point? A symmetric point would be like that, where I'm 3 off of the axis over here, so I have to go 3 off of the axis to that side. So that's how you could find a symmetric point. If I didn't know that point, so this is 3 off of the axis of symmetry. Right? So now I just go 3 off of the axis the other way. So 1, 2, 3. Do you see how from here?
Couldn't you also just do the 3 over
Yep.
9 down on the other side?
3 over 9 down, but I might ask you a question. Can you find the symmetric point? That's why I'm...
Oh.
Yes, but this goes 3, 9, 3, 9. Right? To get both that way. But if I just give you a random point and I say find the symmetric one, you just gotta flip your direction off of your axis.